Okay, so let's get into it. If you are a software tester or test manager, you are likely familiar with the challenge that we have to test more and more software functionality in less and less time. We have to test more functionality because successful software grows. We typically keep on adding new features and only infrequently get rid of functionality. Furthermore, release cycles are shortening. So we see at most of our customers that they have less time to test. So it is important to focus our testing efforts on the areas of our software system where the bugs are most likely hidden. And today we want to introduce you to the test gap analysis that can help you with tackling that problem. If you think that sounds familiar, then you're in good company today. So these are all the different companies that registered for the workshop until last week. And my point that I want to make with this is that the problem with having little time to test functionality of software is something that is happening across all different types of software development and all different types of technologies and languages. So this is not something that is specific to a certain domain, but it's something that we see at several hundreds of our customers. Before we get into it, I will also want to give a short background of who we are. We are the CQSE, and we are a company dedicated to software quality since 2009. We are originally a spin-off of the Technical University of Munich, and we are developing a software intelligence platform called TeamScale. And the test gap analysis is one of the analyses that TeamScale offers across several others. We currently have around 63 employees, and 58 of those have a background in computer science. And around 20 actually have a PhD in software engineering with a focus on software quality analysis. As you can see, we spread across Germany, so we didn't stay in Munich. We opened up multiple different offices across Germany, and also we reached across the pond and opened up an office in California to better support our American customers. My name is Johannes Feilmann. I am part of the test intelligence team here at CQSE, and we are responsible for helping new customers and onboard them to our test analysis. Our workshop today will be structured in 4 parts. So first of all, I want to give some theoretical and technical backgrounds of how the test gap analysis came to be. Then I will jump into some technical details and also show some practical examples, how the test gap analysis can be used and is used by our customers. Afterwards, my colleague Jonas will take over to show you a live demo of TeamScale and the test gap analysis there. And in the last part, my colleague Fabian will take over and show you a cost-benefit analysis of the test gap analysis. Okay, now let's jump in. How do we get the most of our testing resources? And by that I mean, how can we find the most amount of bugs in the limited amount of time that we have for testing? And there is a research field called defect prediction that is trying to find characteristics in software to make assumptions where the bugs are hidden. And across several decades of research, one of the most important factors when it comes to finding bugs that they identified was that the most bugs in long-lived software systems are hidden inside recent changes. And you might laugh now and say, yeah, this is not surprising. If something changed recently, it's more likely to contain bugs. This is intuitive, because if some components of our software didn't change for several years, then it's either working as expected, or if it's broken, nobody cares. And we already see at many of our customers that they try to focus their testing efforts on recent changes. But what we also saw is that it's in practice harder to actually construct tests around recent changes than we initially thought. What do I mean by that? I brought with me here some tickets of some screenshots of our issue tracking processes for TeamScale across the last years. So in the beginning, we wrote tickets by using cardboards and pinning them to a whiteboard. And since this doesn't scale very well, we then moved to a issue tracker software. In the beginning, we used Bugzilla. And lastly, we ended up using, as most of our customers, Jira. Now, one way to try to test the recent changes is by looking at the different tickets that were implemented for a release and then using the information written inside of those tickets, constructing tests. This way, we try to construct comprehensive tests that test out all the functionality that changed for a release. But there are two problems here that I want to highlight now. And the first one has to do with the different types of tickets that can be written. And we analyzed roughly 2,000 of the tickets from our own issue tracker and categorized them into 4 different categories, as you can see here. The biggest part of tickets that we came across were feature tickets. So new functionality that is added to our software. The second bucket were bug fixes, something broke in production, and we had to fix that. Then with roughly 11.6% of the tickets that we analyzed, we found maintenance tickets. So that means the functionality of some area wasn't really broken, but it might be hard to understand, or it was prone to maybe break in the future. So we wanted to invest the time that we had now to prevent it breaking and to make it more understandable when working on it. And the last part of tickets that we saw were tickets with dependency updates. For example, if you're using a third-party library, then this library might have to be updated, and this were the last amount of tickets that we categorized. Now, coming back to constructing tests. If you're looking at the first 2 categories of tickets, it's very straightforward to construct a test around it. So if new functionality is added, then we can test this new functionality. Usually there is some thorough documentation on what this new feature has to do, and this we can test. A bug fix also quite straightforward. We just have to look if the bug is still happening, and if it's not, then our test is successful. But for the last 2 kinds of tickets, it's a little bit more complex, because if we change a maintenance, if we do a maintenance task and the functionality of the software stays the same, it might be harder to construct a test to see if our maintenance was successful or not. Then dependency updates as well might have a huge impact on multiple different areas in our software system. But how do we really test that? If we, for example, update our logging library, then this will affect everything from our software. How can we construct a test around that? So it becomes unclear what actually has to be tested with these type of tickets. And they made around 15% of all the tickets that we analyzed. And we saw in literature, while we constructed this, that this is roughly similar when looking at literature. Now, this is one problem. The other problem that we see is if we construct a test by looking at the tickets and what's written inside of those tickets or documented inside of them, then there are still changes that come through completely unnoticed. And I will give you 2 examples why this might happen. And the first example is quite obvious. So a developer had to implement a new feature, and while working on this feature, he encountered a bug. Now, of course, he does not want this bug to be in production, so he fixes the bug while working on the feature. But he does not document that you fixed this bug in the feature ticket. So if I construct my test just with looking at the ticket, then this might go through unnoticed and also untested. And the second thing that we saw at one of our customers was they had to categorize their tickets in different priorities because they were short on time and they could only work on the tickets with the highest priority, especially regarding feature tickets. Now, the problem was that there were some sales representatives that promised their customers certain functionality of the software, but this functionality might have ended up in a lower priority, so it will not be worked on. And in the next release, the customer wouldn't be happy because the feature was missing. Now, what they did was they had good relationships with the developers. So the sales guys talked to the developers directly and asked them if they could implement the features anyways, without writing tickets for that. Because if they would have written a ticket and it would have ended up with lower priority, then the developer would have had to justify why he was working on that. And so this way, lots of changes slip through unnoticed. And if you have to test something that is not written anywhere, yeah, good luck with that. Now, when thinking about that, we wanted to see how big the impact actually is in production with all these undocumented changes and all the changes that might go through untested. So we did a study with MunichRE, the world's biggest reinsurance company, and we analyzed one of their software systems for 2 releases. And for those 2 releases, we saw that roughly 15% of the whole software changed. And what we found out was that for both of these releases, more than 50% of the changes slipped through completely untested. And this was very surprising. And it's not because the MunichRE has a bad testing process. They actually do what I described before. They had a test manager who looked at every ticket that was worked on for a release and tried to construct comprehensive tests around that. And still, they had this high number of untested changes for the release. Afterwards, maybe those untested areas didn't have a big impact. So we wanted to look at the production defects, and we tracked the production defects back to the code areas of the changed and tested code and the changed and untested code. To no surprise, we realized that the amount of production bugs was 5 times higher in the areas that were untested and changed. After we finished our study and we presented them these figures, they said, okay, this is really nice to know, but it would have been way better if we knew this before we released. And this is what gave us the idea of introducing test gap analysis. Sorry. Now, what do we need for test gap analysis? On the one side, we need the changes. And by changes, I mean really the changes that were done in the software by looking at the changes from the version control system. On the other side, we need the execution information. And this we get directly from the test environments. So we there track what lines of code were executed, and then we can map this back to the changes. And then we have all the untested changes. And to present this, I want to introduce a visualization. This is called a tree map. And this tree map represents a software system. So it actually represents a real-world software system also from MunichRE. Every rectangle that you can see here is now a component in the source code. And the bigger the component is in this tree map, the more lines of code are inside of it. Now I want to zoom in. Every black rectangle now is a file inside of that component. And if I drill down even further, every black rectangle now represents a method inside of this file. And also the same thing holds true than before. The bigger the rectangle, the more lines of code are inside of that method. So we have, for example, this big method over there with lots of lines of code. Okay, now I've used the spatial dimension. Next thing, I want to introduce color. First of all, I want to color in all the changes that were made. So what we can see here now are all the changes colored in that were done for one release. In gray, you can see the methods that were unchanged since the last release. So these are the areas where we want to have less focus on. On the other side, we can see everything that is orange and red now means that this is functionality or methods that were either newly added for this release or they existed before and were changed for this release. Next up, I want to color in the execution information. So now everything that is gray means this was not executed in a test, this method. And green means these methods were executed during test, regardless if they changed or not. Now, all that's left is combining these two information. Sorry, before I want to emphasize that this is the complete information for all manual and also all automated tests, regardless of the test stage. So not only unit tests, but also integration tests, for example, regression tests, that doesn't matter, across all the different test stages and also aggregated. Okay, now we have those two sources of information, and now we need to combine that. And this is the result of the test gap analysis. Again, gray now means this functionality didn't change. Everything that's green now means that the methods were changed or added for the last release and then tested. And red and orange now means these areas changed and were not executed in a test afterwards. So these are exactly the areas where we want to focus our testing efforts on, because these are the areas that are most likely to contain bugs, as we just discovered. And as you can see, there are actually quite big areas of untested code that would have slipped through production to production. Okay. Now, yes?
There's one question in the chat. May I just put that in? So there's somebody asking in a private chat message. By the way, you can also ask in the public chat if you want that. Feel free, then we can already start answering questions. There's one question regarding the test coverage here, because you had it on the slide before. Is it correct that this includes both automated and manual tests? And if so, how do manual tests come in here? Can you maybe elaborate on that?
Yes, sure. So we will touch on that later also, but this includes manual and automated tests. This is very important because we want to have a view of the whole testing efforts that we are doing. We do not want to focus only on a small section of the test, for example, unit tests, but we want to see the whole picture. And we introduce tools called coverage profilers. And those coverage profilers will write down when the system under test is running, they will write down which lines of code were executed, and they don't care about if this these methods or the lines of code were triggered because somebody is clicking through a UI or because a unit test was executed automatically. I will say this again when I'm coming to the technical details.
Okay, sounds great. Thanks for the answer and thanks for the question, and keep the questions coming. We have enough time here to discuss them.
Sure, thank you. Okay, now here. I wanted to say, how do we integrate the information from test gap analysis into the test process? And it is important for us that this analysis is running fully automated, because as I already mentioned, time is of the essence. And it is important that it doesn't affect me as a tester when I'm using this kind of information, because I want to keep on testing the way that I'm used to. So there is no additional effort required here, and all of these analyses are running in the background. We usually collect this information frequently, for example, nightly, if there are nightly tests running. And then in the morning, a tester can look at the results from the test gap analysis and decide if they need to test some areas that are still untested, or if everything is fine. Well, two important caveats that I want to say. And the first thing is, we do not aim at 100% change coverage, at least not all of the time, because there might be functionality in your software where it's okay if they were not tested for a certain release. Because, for example, it's functionality that is not relevant for the next release, or because what is changed does not have a critical, is not critical functionality. Just an example, if the color of a button was changed, then it might be okay that this change in the end didn't work as expected, because otherwise maybe I would have invested so much time into testing this specific button color change that it wouldn't be worth the effort in the end. Also, even if we had 100% change coverage, that doesn't guarantee me that there are no bugs left in the system, because testing can never prove the absence of bugs. It can only show me bugs while coming across them, but it cannot prove that there are no bugs left. Okay, now would also be a good time for questions before I jump into the technical details. Anything in the chat?
Yes,
okay.
Actually, sorry, there's actually one question. Sorry, I was a bit slow. So regarding system under tests, our unit tests run on a different system than the integration and manual tests. How do you combine the results?
So with a different system, do you mean a different version of the software, or just a different system because it's running on a different server, for example? Because
I read the question that this is about different test environments. Please correct me if I misunderstand that.
Yes, that's correct. So we have maybe the same version of the software, but the unit tests run before during the maybe pull request and merge testing, and the integration tests and manual tests run on a totally different system. They are deployed to a different environment, actually. So and you said, okay, you combine the results. How do you do that?
So when we record the coverage, we do that for every test environment that you're testing on, regardless where that is, or if it's multiple different test environments, because we install the coverage profilers on each of those environments.
Okay.
And then in the end, when the coverage is given to TeamScale or uploaded to TeamScale, then we also track on which point of time the development, the version of the software is. And so we can understand in which parts of the software are tested with these different results. And also then we can just declare a name, for example, and say, okay, this coverage that we received here is from UI tests, and this coverage is from unit tests. And this way TeamScale can work with that.
Okay. Maybe I will have another question when it comes to the technical details and what needs to be done and what are the requirements to get TGA up and running.
Sure. Thank you very much for the question. Then I will continue with the technical details. So what do we need to make test gap analysis work? First of all, we need to integrate into the version control system. And we do this by using an account of the version control system that you're using. And once this account is connected with TeamScale, then it will automatically fetch all of the changes that are done inside of it. So for each commit, for example, that is done, TeamScale will get a notification, and then we can see, and then it can use those changes. And I listed 3 different version control systems here. These are just examples. So because these are most of the version control systems that we see from our customers. But even if you would be using some niche version control system that is not listed here, feel free to reach out to us, because we also have some generic solutions where we can work with the information from your version control system. So this is one side. This is how we get the changes. On the other side, as I already mentioned, we need the coverage information from your test environments. And we do this by installing test coverage profilers, and these coverage profilers will be installed on all of your test environments, as I already mentioned. And they will be started up with your system under test. And this will happen completely, as a tester, I'm completely unaware of this because it's just running in the background. And while the application is running, these coverage profilers write down for each line of code that is executed, that they are executed. And in the end, they get this execution information and combine it to a so-called coverage report. And now this report again contains all the information of the lines that were executed during test and those that were not executed during the test. Afterwards, the information is automatically sent to TeamScale, and now TeamScale can use the analysis from the version control changes and the coverage information from your test environments, and in the end, give you the untested changes. Again, I want to emphasize that we do not care what type of tests are executed. So it might be an integration test or a unit test or a manual test. In the end, we want to see a whole picture, and we want to focus on the areas that really slip through the testing completely, where we have no, where we know that if bugs are in there, we cannot have found them. But it's also possible in TeamScale to just select the coverage source that you're interested in. For example, I want to see only the test gaps for the unit tests or the UI tests and work with that. Okay. Do you have questions for the technical details?
Yeah, oh, go ahead.
I'm sorry, I didn't want to interrupt. I hope it's okay. I'm asking this way. So one question, as far as I understand it, TeamScale is kind of a cloud platform, right? So what kind of data is transferred to the cloud? So is leaving the control environment of the project and has been transferred.
So the TeamScale does not have to be a cloud. It does not have to be hosted in the cloud. We offer this as a service, but we also offer TeamScale to be hosted on-premise for customers that do not want to share their source code with the cloud, which we see at some customers.
I see.
But yeah, as I said, we need the information from the version control system, so we need the source code, and then we need the execution information from the test environments. So this is all the information that is sent to TeamScale.
And if it's on premise, then it's some kind of instance where we install the parts of TeamScale and that's been transmitted.
Yes.
Okay,
yes. So,
thanks.
So you can host it completely in your own environment. Okay. Other questions?
And maybe in the same area, if I'm in the cloud and use the SaaS solution of TeamScale, are there any restrictions from the network that is can I send it from my cloud installed application directly to you? Are there any firewalls I need to bypass?
this heavily depends on your architecture regarding how secure or how the security limitations are in your development process. But there are always ways to make this work. And for example, if you need a proxy authentication, or if you need a firewall, if you need to free the firewall, then this can be made. So this is usually something that we can work with.
Okay, and one last question. Which programming languages do you support? Because usual web applications are front end, back end. Are there any limitations?
So we support a wide variety of programming languages. We also have a slide on that later. So during the live demo, we have a slide on all the supported languages and also the languages where we have experience. I think it's easier if you ask the concrete languages that you're using, because as I said, it is a wide variety, and all of the most prominent ones we support.
Okay, then we use TypeScript and C#. I think that's supported.
Yes, so that is supported.
Okay, thank you.
Thank you. Okay.
So no more questions in the chat right now. So go ahead.
Then I will go into into 3 practical examples how we see that our customers use the test gap analysis. And the first example I want to show you is a hotfix test. So there was a hotfix of a bug that happened in production. So time is of the essence because a bug happened in production already, and the customer reported that to the development team, and now the development team is patching what was broken inside of that bug. And afterwards, we need to test that the bug is actually fixed. So what we see here is that there's only a small amount of changes, very localized to the area of the bug. And in the change tree map, this is what we saw. So these are the changes that were made for this bug fix. In this case, this is also a real-world example. So this is a SAP system, and the rectangles here now represent ABAP code. And for this bug fix, we saw that 8 methods were either changed or newly introduced. And afterwards, the tester just did what he is used to. So he tried to cover all the changes that were done with this hotfix. And after he finished his first test, this is the picture that we saw. So now we can see in green all of the areas that were changed and also tested afterwards. And to his surprise, he realized, okay, I guess half of the functionality that was changed still untested. So he talked with the developer and said, hey, I completed my test in the way that I would have done it, but I still see some changes, and he couldn't really understand why. And it turns out that these were changes that had to be done because of some edge cases that he came across while fixing the bug. And since those edge cases are rather important, the tester and the developer decided that they constructed another test, and after the other test ran through, this was the picture. Now we see that everything was actually covered. Another example is the classical release test. So this is what we used to see a lot at our customers. We have a long dedicated development phase, and at one point it said, okay, we now make a feature freeze. Now no new features will be implemented and only bugs will be fixed. And then in this after this feature freeze, we have a dedicated test phase. And in this test phase, all of the functionality of the software will be tested. And if this is completed, then we release. And the example I showed in the beginning of the big tree map, that was also a business information system from MunichRE. And they constructed their release test by giving test cases to a test factory. So they outsourced the testing efforts. And they hired 5 different testers that had to test the whole software system over 2 weeks in 143 test sessions. And they also tested multiple different versions of the system, because after they started testing, they already found some bugs, and they gave that information back to the developers, and they already fixed some of those bugs and then gave them a new version. I said it already, this is what we saw in the big tree map in the beginning. So again, here are all the changes that were made for this release in red and orange. And here is the execution information that we saw from those testers. So this is the execution information from all of the tests that were done by the test factory. And you saw it already. What happened was that afterwards, we still had quite a few areas with many, many untested additions. And we showed them this picture, and then they decided one day before the release. I have to say, this was one day before the release. And understandably, they said, okay, we cannot really release like this because there are still so many test gaps. And if you remember, if in any of those areas a bug would be hidden, they would have had no chance to find them. Now, what happened here? This was not the fault of the test factory, because they did exactly as they were told. They executed the tests in the way that the test managers wrote them. But those were only the regression tests. So they only tested existing functionality. For all the new functionality that was added for this release, they planned on creating automated tests and an automated test suite. But it turns out that this automated test suite actually was never finished. So it was broken and it was never finished. And then none of those tests were actually executed. And this is why all of the new functionality was actually not tested at all. And this is what we can see now in this picture here. Of course, as I said, they postponed their release because the new functionality should be tested. And they did so by doing an explorative test, because they only postponed the release by 2 weeks. They did not have the time to construct test cases and thoroughly construct those test cases to test the functionality. So instead, they just gathered all of the different stakeholders, whether it were requirement engineers or the business and the end users, and then they just let them test as much of the daily functionality that they could think of. And this is also what we call a monkey test. And across these new test sessions over 2 weeks, they also discovered some bugs. So they also tested some different versions of the tests of the software. Now, how did the picture look like after they finished their explorative test? Again, these are all the changes, slightly different because, as I said, they discovered some bugs and they fixed them. Here is now the complete test coverage after they did the explorative test. So this again includes the testing efforts from the test factory and also now the results from the explorative tests. And this is now the picture after they did their additional 2 weeks of testing. As you can see, many of the large areas that were previously completely untested is now looking way better. But still, they discovered 3 areas where the test gaps were a little bit surprising and a little bit bigger than they initially thought. And we analyzed these 3 areas and had a closer look on them. And what we realized was, for the first part on the top here, this was functionality that was prepared for a future release. So this was not something that was relevant for the next release, but for the release after that. So they decided it's okay if this remains untested because it's not relevant right now. The middle part here is also interesting because they realized that this code is actually not reachable at all statically from the application. And after they realized that, they actually decided to delete this area completely. And the last part over here was actually critical business logic that they discovered was untested because it was very hidden in the UI. So they had to click through some multiple drop-downs, and then this was some export functionality. But they saw this as critical, and then they again constructed a test to test up the remaining functionality here. Now, after completing the last test, they decided, okay, now we can ship this, and they release. Now, I said in the beginning, this long development phase into a long testing phase is something that we used to see a lot of our customers. But lately, we see more and more agile development. And as I said, this means that the release cycles are getting shorter and shorter, which I mentioned in the beginning. And usually what we see is that there are multiple different feature branches, and on each of these feature branches, we have the development going on. And then on each feature branch, we have some automated continuous integration pipelines running that have to succeed, where the test coverage is also coming from. And this is a challenge for us, or this was a challenge for us, because we had to keep track across multiple different versions of the software and multiple different sources of coverage. But this gave us the idea that we combine the information from the issue trackers, just as in the beginning, and use the information from the issue trackers to only focus on the changes that were done for a single ticket. Because as a tester, I usually do not really care about all of the different software compartments. I actually want to focus on the areas that are important for me right now, which is usually related to the ticket that I am tasked to test. So what we can see here is now a screenshot from our own development. So these are all tickets that were done by our own development team. And then we can see the test script information for only the tests that were done, only the changes that were done for this ticket. And I can also zoom into this a little bit, because we also get the information from the issue tracker about who was working on it, or who or what the name of the ticket was. And then we can see a very localized tree map of only the changes that happened for this single ticket. And then if I see both of these sources of information, I can now say, okay, if there would be some large test gaps for the changes done in a single ticket, I could contact the developer, which I also see from the information of my ticket system directly in TeamScale. And then I could ask him and say, okay, I constructed my tests, or I executed my tests, but there's still some functionality that I don't understand why this changed. Okay. Now, to get these issue test gaps going, we need, as I already said, we need an additional source of information inside of TeamScale. And this comes from the issue trackers. And it doesn't matter if it's from Jira, Azure DevOps, or whatever issue tracker you're using. We usually have ways to support all of the most common issue trackers that are out there. And also we integrate this information automatically by connecting an account of your issue tracker software. Then what is left is we need to map the changes that were done on the version control system to the different issues. And as you can see already here is we do this by prefixing the commit messages with the tickets that these commits belong to. And if we do this, TeamScale can then connect the changes from those commits to the tickets. Another way to do this is by prefixing the branch names. If you're using feature branches, then you can prefix the branch names with the issue IDs, and then TeamScale also gets this information. And in the end, this is what leads to the issue test gaps.
One question at this point,
Yes.
probably coming back to the previous scenario. If you have a feature in the system for which for future releases, like the one you talked about in that
Yes.
information system case, but prefer not to conduct test analysis for them for this release because it's for a future release, is that an option to exclude a feature from this analysis?
It is an option to exclude components. So when you're creating a project in TeamScale, you can declare which areas of the code you want to have a look at. And if there is some area where you say, okay, this includes functionality that is not relevant right now, then you can exclude it there. Also, you can do this for each of the tree maps that you have a look at. So later when you see the live demo, you can see that there might be different tree maps that you have a look at. And there you can also declare if there are some areas that are not important to you right now.
If I may chime in quickly,
Sure.
I think this is a really good case for this issue-based view on the data, because there you can filter the issues on just the ones that are relevant for the current release. You don't have to look at all the issues all the time, but rather only at, for example, the features for the current release, and then you automatically exclude this part that's not ready to be tested yet.
Thank you for the question.
No more questions right now.
Okay, then I want to hand over to my colleague Jonas, who will show you a live demo of TeamScale.
Thank you, Jonas. I'm quickly grabbing the screen sharing. Okay, I think you should now be able to see my screen. So hello again, everybody. My name is Jonas. I'm the newest member of the test intelligence team, which Johannes actually also is a part of. And we help you guys, or maybe new customers, solve their testing problems. And at this point in the presentation, we have seen a lot of slides about test gap analysis, but we haven't seen it in practice. So that's what we are going to do right now. And for that purpose, we are going to step into the role of a tester who has been assigned to test one specific issue. And of course, we need a system under test for that purpose. And we are going to use DigiBank or Digital Bank. And this is an open source digital banking application, which has been implemented in Java. So let's jump straight into TeamScale. As you can see, TeamScale is a web application, and as Johannes said, it can be hosted both on-premise and in the cloud. And before we begin testing, I would just like to explain to you what we can see here. We are starting out in the so-called activity perspective. And here we have a list of all the changes or the commits that affected the specific branch we are looking at right now. So here at the top, we could select a different branch, but this is actually already the feature branch we are interested in. And also here to the left of it, we could select another project, but DigiBank is our system under test. Then here on the left, we have a navigation bar, and we could, for example, select maybe metrics and have a look at a bunch of different metrics for our source code. Instead, we are going to jump into dashboards, because in the dashboards perspective, you can combine a number of widgets to show just the information you are interested in. And as you can see, one of them is the test gap tree map. By now, you already have seen a lot of test gap tree maps, but not how to interact with them. So we're going to do that right now. If I hover my mouse over one of these methods, it shows me this pop-up, and apparently this method is called savings view, and it tested its latest modification. It also shows me when this method was changed for the last time and when it was executed. Now, of course, I might only be interested in one of those components. And if I click on the method, I get this different pop-up, and I could, for example, just select this directory web. And this shows me all the methods in this directory. And this is actually our method from before. This is savings at. Now I can also click on savings at and click on open method savings at. And this is going to show me a list of all the changes that affected this specific method. We might also be interested in all the changes that happened to this specific method since the last release. And so here on the left side, we can see the original version at the last release, and this is the changed version. Now, since we are doing test gap analysis, we might also be interested in the coverage we have for this specific method. And for that purpose, we can go here and click on savings at. And here we see the code of our method. As you can see, there are a bunch of lines with different colored backgrounds. And this color tells us whether this specific line has been executed or not. So green lines are obviously executed. If we scroll up a bit, we see red lines. So these have not been executed. And then finally, we have some white lines, and those are the lines that actually can't be executed. So that is, for example, the case for all of the blank lines. And finally, we have these blue lines. Those are just the same as white lines, just that these belong to the method we selected. So this is savings at. Great. Now that we know how to work with one of those test gap tree maps, we can begin our testing. And for that purpose, I'm going here to test gaps and issues. And this is just a list of all the issues that in this case are assigned to me. We could also have a look at, for example, the issues that have been part of release 2.1.0. So that's exactly the question from before. Or we could craft our own custom query, just as we could do that in Jira, for example. Of course, right now we are only interested in my issues. Yeah, and this is actually the specific issue we have been assigned to test. So let's go into that. And here at the top, you can see the issue number as well as the title, who implemented this. Then we have a description, here are the test gaps, and here at the bottom, we have the commits that have been linked to this specific issue. And as Johannes explained, we do this using this prefix in front of the commit message. And we also do it in this case using the same prefix here in the branch name. Okay, so this specific issue is about preventing depositing negative amounts to bank accounts, because that would be equivalent to a withdrawal. And we obviously don't want that. And to test this, we want to conduct a manual test. And for that purpose, I'm going to start up a test instance of DigiBank using this little script. And actually running together with, let me just copy that real quick. Actually running together with our test instance is the coverage profiler. So while I click through this UI, it's already recording all the lines of code that are executed. So I, as a tester, don't have to worry about anything. And we are interested in depositing. So we just go here, we select an arbitrary account and deposit a negative amount. And that didn't work. We got an error message that our amount has to be greater than 0. And in this case, this is exactly what we expect, because as you remember, our issue is about preventing such negative deposits. So from our point of view, this implementation works perfectly, and we can stop our test. So I'm just going to do that really quickly. And this is actually also automatically uploading the coverage we just generated to TeamScale. And if we go to activity, you can see right here at the top, the coverage that we just generated. Now, before we finish our test, we want to have a look at the test gap tree map for our issue. And I'm going to show you a quick shortcut. Because as I said, we link the commits to the specific issue. And that's the reason why we can go here and just click on the issue, and here we are. And here we have the test gap tree map for the issue. And as you can see, there are 3 methods already executed by our test, but there's one method which we didn't execute apparently. And this pop-up tells us it's called withdraw. And that's immediately fishy to us, because if you maybe remember here in the description, actually withdrawing something is not mentioned. So we don't know why or what has been changed in here. And at this point, we could go into the code and just check what has changed, but we don't want to do that. And instead, we're going to talk to the developer and ask them what's changed. And of course, we don't have a real developer in the background right now, so just assume I did that. And they told me that during the implementation for this issue, they found a bug in withdraw and just fixed it right away. So also exactly the example from Johannes' slides. Now, that's perfectly fine, of course, but at this point, we have to decide whether we want to test withdraw again or not. Because test gap analysis is not trying to take the decision from us. It just shows us the information so that we can do an informed decision. And in this case, I would like to do another test because withdrawal seems to be pretty important for a digital banking application. So I'm just going to start up our testing instance again. Here we are. It should be easier this time. And I'm just going to withdraw something. Also a negative amount because that's the issue. Let's see if it works. And apparently that worked. And we now own an obscene amount of money. So that's obviously a bug. And we have to report a bug for that, or we have to talk to the developer so that he fixes this before closing the issue. And we are going to do that. But before we do that, we are actually also going to stop our test. And similar to before, this automatically uploaded all the coverage we just generated to TeamScale. And with that coverage, we can have another look at our test gap tree map. And as you can see, now all of the methods have been executed, also withdraw. And that's an important point to take, because test gap analysis only knows whether a method has been executed, not whether the test has failed or not. So we are actually focusing in test gap analysis on all the test gaps, the red and the yellow ones, because for those we didn't have a chance to find any bugs. Now at this point, we would go to the developer and ask them to fix the bug. And again, we don't have a real developer right now. So we got a little script to do the fix for us. And I'm just going to do that right now. And actually, if we are quick enough, we can see TeamScale analyzing the change that has just been made. It should just take a few more seconds. And here we are. And this is the change that the Andrew did right now. Can have a look at another look at the test gap tree map. We scroll down here, here it is. And as you can see, one method changed and it's withdraw. And that makes perfect sense because that was the method where our bug was located. Of course, at this point, we again have to decide whether we want to test this again. And in a real world scenario, I would probably do that. But you already saw how to test withdraw, so we're not going to do that again. There's one more thing I want to show you because we already talked a lot about different test stages and manual tests and automated tests. So right here, we could select different kinds of tests, for example, to select which coverage we are interested in. And if I deselect manual tests right here and click apply, it's going to show us the tree map we had in the beginning without all the coverage we just recorded in our last 2 tests because those were manual tests. And just go back to the full tree map. Okay, then I have one final point to make, and that is even without looking at the code, we were able to find a bug just by looking at the test gap tree map during testing. And that's what test gap analysis does. And that already concludes our live demo. So if you have any questions, now would be a great time.
Hi, I have a very quick question. In the previous thing, like you told that if at all I wanted to exclude some of the components, we can do it. But I'm not really sure, like, how do we do that? Or did I miss out something?
Yeah, so we have different points for that purpose. For example, we can go into the test gap tree map, and we could, for example, here in the path, select a certain path. We could also define a so-called architecture to exclude certain components from our test gap analysis in total. Then we have this other thing where we can click on a method and just click on the path just to see the test gaps in those in this directory. And also the issues right here. So you could select maybe just the issues for the last release, just as in this query. So you don't have to look at all the test gaps that are in issues you aren't interested in right now. And finally, it actually also is possible to just exclude certain paths, for example, from the analysis in total. Does that answer your question?
Yeah, so that means there are different ways of doing it, right? Because in the tree map directly or in the project configuration, I can do it,
Exactly.
or only the release. Ah, okay. Thank you.
No problem. Thank you for the question. Any other questions?
If I may ask, if I understood it correctly, you are comparing different branches of the versioning system. So this is for you the changed code, right?
Exactly. So we
and I
sorry, go on.
Yeah, and you just define in the cockpit which branch which branches you want to compare, and this makes this what has changed in the overview.
I see your question. So there are actually multiple answers. We are analyzing all of the branches, or actually all of the branches we want to analyze. We also can exclude those. But the changes you see right here, they are computed on the same branch. So for example, these are all the changes on the branch prevent negative deposits since the last release, which in this case is the 21st of May 2020. So we just compare the changes that have been made since a certain timestamp, and those are the changes we see right here marked as green, yellow, or red.
Okay, and then I have to define the time, or the start of the time and the end, and which one to compare. Okay, and this I'm doing in the cockpit as well. So this is nothing I need to, I don't know, administer in the version control system or on the code or something like this, or on the comments.
Yeah, exactly. So you could, for example, here in the tree map, you could select it just here with so-called baseline. And for the issues, it's actually done automatically, because for the issues, we know which commits are relevant. So we just use all the changes from these commits, and you don't have to set a baseline or a start date at all. Does that answer the question?
Yes, it does. Just to make sure, there's nothing to be edited in the code, or there's nothing which has to be changed in, I don't know, writing code or something like this. So kind of tags or triggers or something like this, it's not necessary.
Yeah, not at all. That's not necessary. Of course, we have these prefixes in the commit message, which are necessary for this linking. And for recording the coverage, we also need to instrument the code. So I think the coverage profiler are actually introducing some small statements that tell us where the code is executed right now, but that's not relevant while developing the code.
Okay, thank you.
Thank you for the question. Are there any more questions?
There's no questions in the chat.
Okay.
So guys, if nobody speaks up, just go ahead.
Thank you. In that case, I'm going to jump back to my slides. and I'm going to show the one slide Johannes already mentioned. These are the programming languages we support. And in orange, we actually have all the programming languages where we have the most experience with, because a lot of customers use them. Maybe your programming language or the programming languages used as your company are mentioned here as well. So here's, for example, TypeScript as well. Yeah, and then with that, I'm passing the beacon to my colleague Fabi.
All right, thank you very much. Okay, and even if the languages you use are not on here, you can contact us. We keep adding new languages here all the time, and profiling solutions as well. So we're always interested to hear what people are using and what might be interested to add to the list. All right, that concludes the demo part. In the final part, I will talk a little bit about cost-benefit analysis, because we've seen a lot of what can it bring, and you can see on the website what does it cost, but actually it's quite a hard problem to quantify what are the actual benefits out of the analysis at the end. Because what we're trying to do here is, of course, reduce production defects and that way save money in the end. And measuring how much money we save with test gap analysis is quite a challenging task. And we proposed that task a few years ago at MunichRE, where the CIO of the company changed, and the old one knew all of the history of how we set up TGA and why we did it, but the new one was completely new in the company. And so they asked the question, is it really worth our while to spend effort and money on test gap analysis? And so we had to justify that really helps them more than it costs them. And I'm showing the results of this cost-benefit analysis that we did at MunichRE, and I'm allowed to show this because in the end they presented it together with us at the OOP conference, so this was also publicized. And measuring the benefits of the analysis in terms of money, euros, dollars, what have you, this is really complex and really hard to do because, of course, every production defect has a different impact even at the same company, and it will have quite a different impact at a different company then again. So we actually did not measure it in terms of euros, but rather we just looked at how many production defects are they actually saving now that they've been using test gap analysis for several years. And I'm going to show you how we did that. So at MunichRE, if you remember back, those were that was the company that we did this study on before they were using test gap analysis. So we already had some data about several actual systems at MunichRE about how much production defects did they have before they used test gap analysis, and how was that distributed between the untested code changes that we're focusing on with test gap analysis and the rest of the system. So that really helped us make this study, because now we have data from before and data from after using test gap analysis. So the things you should remember for the next slides to make sense from here is that more than half of the code changes that they did for their releases went into production completely untested. And we always try to be conservative in this study. So instead of taking the higher number, we took the lower number, so 50%. And it's 5 times more likely for bugs in production to occur in these untested code changes than in the rest of the system. And with these two facts and what the numbers look like today, we could show them how much production defects they actually saved. And for this, our mental model that we applied here is that when we do testing for a certain amount of changes, so the red area here is everything that we changed for the release. When we do testing, then this is sort of a filter on the bugs. A few of the bugs that are in the system are found by testing, and a few others are not found by testing. And that really tells us how much remaining bugs we have. And we can now use the numbers that we had on the previous slide to show how many bugs slipped through testing before they used test gap analysis. So we know as the first fact that half of the code changes were not tested at all by any of the test stages. So for those, any bugs that were in there cannot have been found. We can only have found bugs in the left part of the graphic. And here some of the bugs will have been found by testing, but not all of them, because testing is not 100% effective, but rather a few bugs will still be in there, even though the methods were tested. And in this case, we know that it's 5 times more likely for a bug to be on the right side here in the test gaps than on the left side. So we know that if we have found none of these 5 bugs here, then we have found 4 of the 5 bugs on the left side in this graphic. So 10% of the bugs in the whole system that are represented here on the left side also slipped through the testing because the testing was not 100% effective. So in total, that gives us 60% of the bugs that slipped through the testing that they did before they had test gap analysis. We can do the same thing now that they have test gap analysis. And for this, we looked at the whole application portfolio, which was, of course, many more applications now than it was that we had data on back then, because they rolled it out to a lot of applications. So this was several dozen applications that we looked at here. And again, to be conservative, we now took the worst numbers that we found, so that if we make an error, we at least make it in the right direction and we underestimate the effect of test gap analysis. And this time, the worst test gap that we found across all of these applications was 10%. So this means 10% of the bugs still slip through testing completely untested and thus can't have been found. So those are definitely still in there. For the rest, we can still make the same assumption as before. It's 5 times more likely for a bug to be over here than it is to be back here. So again, 20% are going to slip through our testing here. And that would be 20% of the remaining 90%, so 18%. And that in total means, if we round up, again, to be conservative, around 30% of the bugs still slip through testing from MunichRE. And that in summary means, compared to before they had test gap analysis, the testing is now about twice as effective. So they find only 30% slip through instead of 60%. So they save 50% of the production defects. And that result for the new CIO was convincing enough for them to continue with test gap analysis, and also for them to publish this result together with us at a conference. And of course, if you now think about transferring this to your own development, it will not be 100% transferable, because you'll have different test gap numbers and you'll have a different system and you'll have a different amount of production defects and so on. But from my experience working with different customers, at least the test gap numbers are very comparable across different customers. If you've never looked at this data before, you will likely have something around 50% of your changes slipping through testing. That's not unusual. And so we can expect large savings at pretty much everyone who tries this out for the first time. So much for our study on cost-benefit analysis. Any questions about that? Be happy to take those. Otherwise, this concludes the talk. So if you have any general questions, you can also ask them now in case anything was left open.
Currently, no questions in the chat.
All right. Then thank you, everyone, for joining the talk. We're also happy to repeat the talk in case you found it interesting, but you have some colleagues who you'd like to also get to know about this. We're happy to do a free workshop at your company where we basically repeat this talk, can customize it for whatever is interesting for you guys. And you can ask all the detailed questions about your situation that maybe don't fit so well in the public workshop format. So if you're interested in that, let us know, and we're happy to schedule a session with you guys. I'll also do a few talks that we'll have in the future. There is one in German. I noticed a few German people are here today. That will be next week, where we show basically how we applied this technique at Allianz Technology, a customer of ours, and how they used it for their purposes. So it will be mostly Nadia from Allianz talking about this. and I'm only there to explain a little bit how the analysis works. So if that is interesting and you speak German, I invite you to come join that as well. You get the link in the slides that we send around later on. And in English, we have another one at the end of October about a different topic. This is again an analysis that TeamScale can do for testers, where we try to solve the problem that many of our customers have, where test suites grow over time and they grow so much that they take really long to run, and that makes it really painful because everyone has to wait days or even weeks until they get results from the tests, and we help you speed that up again. So if that is interesting, also feel free to join here. It's free as well. Before you leave, we have a small poll where you can quickly tell us with 2 clicks if you liked it today. That would be really helpful for us. My colleague just enabled this, so please just let us know if you liked it. And when you leave the talk afterwards, there will also be a big feedback form popping up. If you have any free text comments that you'd like to leave us, that would be really cool. So thank you very much if you do that. Otherwise, we're done for today. If you still have any questions, you can stay on. We'll be here for like a quarter of an hour longer, and you can ask questions. And for everyone who's leaving us now, thank you very much and have a nice day.